So in this example, we're told that these two segments, CB and EF, are parallel, and also AB is parallel to ED. And they want us to use a protractor to see if these two angles are equal in measure to each other. So the lines, the sides of the angles were not long enough, so I went ahead and extended them. And then for this first angle, I'm going to put the vertex right on my 0 and my base side along the bottom, and that looks like it's going to be a 45-degree angle. So we would say the measure of angle B is 45 degrees. And the nice thing about the protractor is you can move it around to match any shape you want. We'll put our vertex right on the end angle and our base right along our protractor, and it also looks like the measure of angle E is also 45 degrees. So their measures are equal. So if the measures are equal, we would say the angles are congruent. So two angles with equal measures are said to be congruent. And so here we see that in figure 33 here, angle ABC is 33 degrees, and also angle CBD is also 33 degrees. Since the angles have the same measure, the angles are congruent. Now, we would not want to say the measure of angle B is 33 degrees. That is ambiguous because we wouldn't know, did we mean this angle that has B as a vertex? Or do we mean this angle that has B as a vertex? Or you know what, how about ABD there, the 66-degree angle? So in this particular case, you have to use the three-letter angle name so that there's no misunderstanding. Now, as you see, here's this ray. It has an endpoint and goes on from point B up through point C and beyond. Notice that breaks this larger angle into two equal angles. A ray or a segment, anytime an angle is separated into two smaller angles of the same measure, or two smaller congruent angles, they are said to be bisected. To bisect something means to break it into two equal parts. If it's broken into three equal parts, the word would be trisect. Bisect breaks into two equal parts, trisect breaks into three equal parts. So we actually saw our first angle bisector in the previous example. And then here are just some special angles. A straight angle is equal to a straight line. So here's my vertex, and it's going, here's one side and here's the other. So it's the measure of a straight line is 180 degrees. So we have straight angle, and then there's also a right angle. The measure of a right angle is always 90 degrees. That looks like the corner. And our notation for a 90-degree angle, what you're going to see is we're going to put a little box there. That's the notation showing that that is a 90-degree angle, and that's also called a right angle. Straight angles are 180. Right angles measure 90 degrees. So if parallel lines never intersect, there's another type of intersection, and that would be a perpendicular intersection. So when two lines intersect, lines will always intersect at a single point. If when two lines intersect, they form congruent, same shape and size. Adjacent, adjacent means touching. Adjacent means they share a side. So if it creates congruent adjacent angles, then they are perpendicular. They're meeting at 90-degree angles. If this angle and this angle have to be the same size, this one would have to be 90 and this one would have to be 90. If this one and this angle have to be, angle 3 have the same measure, this would be 90 and 90. So lines that meet at 90-degree angles or create congruent adjacent angles are perpendicular. And let's see, that's angle T and angle R. We would say T is perpendicular to R. So that's your symbol for perpendicular. And then one last thing about angle measures, segment measures. You may not use a ruler. You may actually do some calculations. So here I have segment AB, and here we have M is the midpoint. That means AM is congruent with MB. Same length of these two segments. So they want us to find AM if AB is 15. So if the whole segment is 15, half of 15 would be 7.5. AM would be 7.5. This one would be 7.5, and this one would be 7.5. Question B here, they want us to find the whole segment, find AB if AM is 4.3. So if between AM is 4.3, 2 times 4.3 is 8.6. The whole segment would be 8.6 if it's bisected into two 4.3 segments. And finally, they want us to find the length of the whole segment if the length of segment AM is 2x plus 1. Well, if this is 2x plus 1, AB is going to be 2 times 2x plus 1. And if we distribute that 2 into the parens, we would get 4x plus 2. That would be the length of segment AB. So we're done with the preliminary chapter. Enjoy your homework. Bye-bye.